Alright guys, welcome to the channel. We got a 2005 Honda Accord here today. Customer complaint is the blower motor is not working, or there's no air coming through the vents. So the first thing we're going to do is we're going to pop this kick panel off underneath here. It just comes loose with plastic clips. You pop it off on the front, and then it's got some guide pins on the back, as you can see, that you just pull out from. So first thing we'll do after that, I'm going to take out my multimeter, back probe the connector. Right, here's your blower motor right here. Here's your connector. I'm going to back probe that to make sure we're getting power and ground here. And the main reason why the first thing I'm not going to do is go check fuses is because even if we saw that the fuse and relay was good, we'd still have to come here and verify we're getting power and ground to the component. So I'll get that set up, then I'll get you guys turned back on. All right, we're back. I've got the blower motor connector back probed. And for anyone that's unaware, the reason why you do this, instead of putting the terminals of the multimeter in the front side of the connector, is because by doing so, you can stretch out those terminals. And so when you plug it back in, you can have poor pin fit and gaps inside terminals that have a lot of current going through them, which blower motors do. You can create a lot of heat and plastic can melt. So a lot of bad things can happen from front probing is what they call it. So we back probe by putting these metal T-pins up through the back side of the connector. We've got it connected to our multimeter down here. And so the purpose of this test essentially is making sure we're getting power and ground to our component. If the power and ground is getting to the component, 9 times out of 10, you can condemn the component. The only thing you want to be aware of is sometimes you'll have corrosion or wires can get damaged. And if that happens, you want to make sure that you can transmit a load through the wire. So you would typically apply a load to the power ground side, make sure you're getting enough current. With these wires being as large as they are, I don't think we need to do that test. So I'll start the car. As we can see, we're getting 13.6 volts, which is pretty typical voltage when the car's running. So we are getting power and ground to the blower motor and nothing is happening. So I'm going to go ahead and pull the trigger that this is a bad blower motor. Now every now and then you can test that. Sometimes these blower motors will get stopped on a contact where they're dead. Every now and then you can hit them. Sometimes they'll turn back on, just like that one just did. So we definitely have a bad blower motor. So we'll get to replace that real quick. So to replace this blower motor, you push down on this tab, pull down on the connector, and then you're going to see there's 3 T20 screws around the perimeter of the blower motor. Take those out, it'll fall right down, and then installation is reverse the removal. Pretty simple, and I'll show you what happens, what it looks, how it functions once we get it all put together. Got the new blower motor in, the 3 T20 torque screws tightened around the edges, connector put back in. Turn the switch on. It's functioning just like it's supposed to. So pretty easy job, pretty self-explanatory. Mostly I just wanted to go through the quick diagnosis process of, you know, why I started where I did. Didn't waste any time at the fuses because we would have had to come and check the voltage and ground here at the blower motor anyways. So hope this was helpful.